the box plots. Sometimes they are called the box and whisker. Plots. So you can call them either box plots or box and whisker. Now this is also another way of presenting data for easy interpretation. Now how you construct this? This is what you need. So I'm saying to construct the box plot, you follow the following steps. Follow the following steps. 1, you rank your observation. You rank the observations from lowest to highest. So meaning that you rank your observations in ascending order. And then 2, you rank your observations. So after you rank your observations, you calculate now. You calculate the quartiles, which are also called the percentile. So I'm saying calculate quartile 1, quartile 2, and quartile 3. We are calling quartile 1 as the lower quartile, and then the middle one as the middle quartile. So I wanted to say the median, but yes, this one is just called the median quartile, and then the upper quartile. So you have the lower quartile, the median, and the upper quartile, which are also called the percentiles. And then you also calculate the mean of the data. And then step 3, you calculate quartile 1 minus 1.5 of the interquartile range. So you multiply the interquartile range by 1.5, so that if the observation falls below the lower quartile, I mean below the figure that you obtain here, below quartile 1 minus 1.5 of the interquartile range, then it is an outlier. It will be called an outlier. Step 4, calculate quartile 3 plus 1.5 of the interquartile range. If the observation falls above above the quartile 3 plus 1.5 interquartile range, then it is an outlier. And then the fifth step, is a construction step. And so in a case where there are no outliers, construct the box plot as follows. So it will be, you have a line of the data, but from this line, you just want to pick the lowest value, and then your quartile 1, and then your quartile 2, and then your quartile 3, and then your highest value. Then from quartile 1, that's why you're drawing a box. It goes all the way up to quartile 3. And then the middle quartile, you break here. And then if your mean falls to the right, then you put, if your mean falls to the right of this, suppose your mean is here, then you would put a plus there. And then you draw a line there to the highest value, another line to the lowest observation. It's what you're going to be calling a box plot. So you just make sure that you're drawing this box here has its edges on the quartiles, quartile 1 and quartile 3. And then its middle line, this line here, is on the quartile 2. And then this plus here will move depending on where you find your mean. If the mean will always be in this box. The mean can't be far away from the central line there. Now, how do you obtain the quartiles? Let's talk about how to calculate the quartiles. So you're saying, first for the mean you know, you just add everything and divide by total number of observations that you have. Okay. So as I mentioned, that the quartiles are just the percentiles. And now they just separate some data depending on which quartile that you are dealing with. And quartiles will be values in the data. Okay, so how do you calculate? So the one we call quartile 1 is the same as the 25th percentile. The one we call quartile 2 is the same as the 50th percentile. And the one we call quartile 3 is the same as the 75th percentile. So below, in between, above. So now to find these percentiles, we are saying to find the percentiles, what do we do? First thing, we locate the first how do I put this in a simpler way? Okay, the first one, just put a general statement in. Let's just say to find PM, we first locate its you locate its position in the ranked data. Ranking means in that order of one from the lowest to the highest. After locating the position, then and how you locate the position, you evaluate. So because I want M, so I'll say M over N, the total number, and then multiply by. So here, you get the same value. For example, if I have 20 observations and I want the 25th percentile, so I'm going to say 25 over 20. And then I get some value. The number I get, if the number I get in my calculations here, if the number I get here is of course, the number that you get here, you add something like, if a number has something like a 0.5, then you go straight to the next position. Okay, now you're going to understand this in an exam, because I'm trying to avoid a lot of formulas here. So let me just go in the example, and then I'll demonstrate well, so that I don't lose anyone here. The formulas that you have are not necessary for this course. So let's just do an example, and then I'll explain well for you. So we're saying, example 1, construct the box plot for the following data. The data 27, 32, 47, 54, 36, 44, 56, 49, 53, 51, 35, 29, 62, 19, 65, 37, 48, 33, 41, 45. The procedure here is saying rank the observation first. So you need to rank the observation. Now the best way of ranking this, you can use the stem and leaf, where we say, how many digits do we have here? We have 1, 2, 3, 4, 5, 6, 7. So I'll end there. I don't think there's even something. Then for ones, we have 19. And then for 20s, we have 27. This one has gone. And then we have 29. Then 30s, we have 32. We have 37. We have 33. We have 36. We have 35. Then 50s, 40s, we have 47. We have 48. We have 44. We have 41. We have 45. We have 49. 50s, we have 54. We have 56. We have 53. We have 51. 60s, we have 65. We have 62. So this is not an ordered one. Then you can quickly do an ordered stem. Ordered stem and leaf. Where you say stem and then leaf. It is 1, 2, 3, 4, 5, 6. So for 1, we only have 9. For 2, 7 and 9 already in order. For 3, we have 2, 3, 5, 6, 7. I'm just ordering now. For 4, we have 1, 4, 5, 7, 8, 9. For 5, we have 1, 3, 4, 6. And for 6, we have 2, 5. So now I can put the data in order. The data we have is 19, 27, 29, 32, 33, 35, 36, 37, 41, 44, 45, 47, 48, 49, 51, 53, 54, 56, 62, 65. So we have ranked the data. After ranking the data, we now calculate the percentiles. Say, okay. The next page, quarter 1. Quarter 1 is.
So I'm kind of asking for the previous page. Okay, sir, thank you. I've captured.
So quarter 1 is 25.
Sir, me haven't captured.
So we count the data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 observations. And then to get the percentiles, you say 25 out of 100 multiplied by 20 observations that we have. The number we obtain here is 0 here. That is 50 by divided by 10. That's 5. This 5 we have gotten is a whole number. Because it's a whole number, the quartile will be on the position 5th plus 6th position over 2. So we'll get the average of those two positions for us to obtain the Q1. So now we're looking for the 5th and 6th, and then we'll get the average. So we go and look. The 5th, 1, 2, 3, 4, 5, 6. So add 33 plus 35. So we're saying Q1 is 33 plus 35 over 2, which is equal to 34. Because that is that is 68, and then you divide by 2, you get 34.
Can you please explain again? My network cut.
So we have 68 divided by 2, which is equal to 34. So I'm saying for you to get the first quartile, it is the 25th percentile. So you get 25 out of 100, and then multiply by the total number of observations. If you get a whole number, then you get the position of that whole number plus the next position, and then get the average. If you get a decimal, if here we got 5.6, would have just gotten the 7th position for us to get, not necessarily 5.6. Let's say you get 5 point, anyway, even 5.6. You just get the next whole number, so it would have been the 6th position. But in this case, we got 5, so you get the 5th and the 6th position, add them, and then get the average as your first quarter. Then Q2 is 50 out of 100 by 20 observations. So we have 5 by 2, which is 10, another whole number. So you get the 10th plus the 11th observations, and then divide by 2. So I'm saying Q2 is equal to the 10th. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 44 plus 45. 44 plus 45 over 2. This is equal to 44 plus 45. That's 89. Divided by 2, you get 44.5. And then Q3 is 75 over 100 by 20. So this is 7.5 by 2, which is 15. Quartiles and percentiles are the same thing. So 15, then you get the 15th plus the 16th, and then divide by 2. So Q3 is the 15th term. We count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the 16th. So that is 51 plus 53. 51 plus 53 over 2. That is 104. 51 plus 53 divided by 2. That's 52 as our Q3. And then you get the interquartile range. How do we get the interquartile range? The interquartile range is just Q3 minus Q1. Q3 is 52 minus Q1 is 34. So altogether we get 52 minus 34. We get 18. And then you calculate. So here now we said you calculate quarter 1 minus 1.5 of the interquartile range, which is going to be quarter 1 is 34 minus 1.5 multiplied by 18. This is equal to 34 minus 1.5 multiplied by 18. So we get 7. And then quarter 3 plus 1.5 interquartile range. This is quarter 3 is 52 plus 1.5, 18, which is 52 plus 1.5 multiplied by 18. That is 79. Then now you can construct your box plot. I know we haven't found the mean, so we need to find the mean. So what's the mean? The mean we know, we just calculate all the values. So for the mean, you can denote like that. You calculate, you're summing all the 20 values and then divide by 20. So what's the sum of these numbers? So when you sum all of them, 19 plus 27 plus 29 plus 32 plus 33, they should give you 863. So that the mean becomes 863. Then you divide by 20, which should give us 43.15. Now we have the mean, we have quarter 1, we have quarter 2, we have quarter 3. And you can see, we say that when you have those things, then you plot like this. You get the lowest value, the highest observation, quarter 1, quarter 2, the mean, quarter 3. So we arrange them. We'll put it here. The lowest observation that we have is 19. So we get 19. And then the highest observation that we have is 65. So you put 65. And then quarter 1 is 34. So you put 34. And then quarter 2 is 44.5. So we put 44.5. And then quarter 3 is 52. 52. So you can draw the box, and then in between here, you cut and then look for the mean. The mean is 43 point, so it's this side, 43.15. So the plus will be this side of the box. And then you plot here and you plot here. This is because we don't have n numbers in our observation that is higher than 79 or lower than 7. If there was to be a number higher than 79, then that number would be placed after 65. That is, for example, if this number here was to be, 63, this number here was to be 63. On our box plot, would have put 62 here, and then 65, which would have been above 63, would have just put a star at 65, showing that it's an outlier. Okay, but then now we don't have such a thing, so we don't do that. So there must be another example where such a thing should work out. Okay, this was the first example. Maybe we can have another example later on. That is tomorrow. For now, these guys have started joining, I think.
So just wanted to ask.
You can go ahead.
Yes, I'm just behind on like the reason why we were finding these values, where we were adding Q1 plus C 1.5 IQR. Yeah, I'm behind on.
So wanted to use these numbers to check if there's any outlier. The numbers we call outliers, those numbers that do not tell us anything about the data that we have. They are far away from the other observations. For example, you have observation 1 at 20, 27, 20, 32, everything is scattered here, and then again 101. So this number is far away from 20. Again, from 32, you have 101. So you get less information on these two, but you have more information from here because even the mean will be scattered around these numbers. The median will be around these numbers. So we call these numbers outliers. And so to check if there are such numbers, we calculate these two. That's the whole idea why we're calculating. So maybe in the next example, which will be example 1, tomorrow, we'll look at an example which will have outliers so that can appreciate why we calculate all these values. What topic? Statistics. Statistics on the data collection methods and data presentation methods. So we'll need one more example on the box plot, and then look at how to get the median and the mean, the mode of interval data, and then move to distributions, then probability. So we end here for now. Okay, we can end here because these guys for 1100 have started joining. So we can end here for statistics and then log out, log back into revisions for 1100. That's in between 1100 and 1120.